stand in the trench beside the unfinished obelisk at Aswan and run your palm across O. The stone, and you will feel something that shouldn't be possible. Ripples. Rows of smooth, curved scoops one after another, cut into granite hard enough to shatter a steel chisel. For a moment, your hand tells you a machine did this. And in 2024, that exact feeling went viral because someone did something nobody had tried before. They fed thousands of close-up photographs of these marks into an artificial intelligence system and asked it a simple question. What tool made these cuts? The answer that spread across the internet was electric. The AI, so the claims went, rejected the accepted explanation entirely and concluded that only a machine with a fixed cutting radius could have produced marks this precise at a depth of thousands of years before anyone believed such machines existed. Millions of people watched, shared, and asked the same question you might be asking right now. Did we just get proof that ancient Egypt possessed technology we've spent 2 centuries pretending never existed? The honest answer is no. But the story of why the answer is no and what was actually happening in that granite trench 46 centuries ago is more interesting than the myth, not less. So let's take this apart properly, piece by piece, and get to what the evidence actually shows. First, the claim itself needs to be understood for what it is. Large language models like Grok are not measurement instruments. They don't carry lasers, calipers, or spectrometers into a quarry. When you upload photographs to a chatbot and ask it to analyze tool marks, it is not performing forensic metrology. It is generating a plausible-sounding block of text based on patterns in its training data, shaped heavily by the way the question was framed. If you ask an AI to evaluate whether a set of marks is consistent with hand tools, using neutral open language, you tend to get a cautious, hedged answer. If you tell it to compare the marks against modern industrial machining and prime it with words like precision, uniform, and impossible, you tend to get exactly what you primed it to say. This isn't a flaw specific to Grok. It's true of every large language model, and it's precisely why serious researchers don't diagnose ancient stoneworking from a chat window. The claims about 5% tolerances and radius consistency that circulated online were never published, never peer-reviewed, and were never independently measured by anyone with calipers standing in the actual quarry. They exist because a chatbot wrote them down, and because a wildly specific, seemingly scientific number is very persuasive when nobody checks where it came from. So if the viral claim is not evidence, what actually is? As it happens, we have a genuinely rich body of evidence about how the Egyptians worked granite, built from more than a century of archaeology, hardness testing, and hands-on experimentation. And the real story doesn't need a hidden machine to be remarkable. Start with the stone itself. Aswan granite is an igneous rock made mostly of quartz, feldspar, and mica, and it sits at roughly 6 to 7 on the Mohs hardness scale. That's harder than a steel knife blade and vastly harder than copper, which sits around 3. This is the detail that fuels most of the mystery, and it's a fair one to raise. If the Egyptians' main metal was copper, and copper cannot scratch granite, how did they cut it at all? The answer is that they largely didn't cut granite with copper edges doing the work directly. They used copper as a carrier for something harder, sand. Quartz sand, which is abundant along the Nile, sits at 7 on the Mohs scale, hard enough to abrade granite even though the copper tool holding it is soft. This is the same principle behind lapidary work today, where a soft blade loaded with an abrasive slurry does the cutting, not the blade material itself. Egyptian masons used copper tubes and copper-toothed saws in combination with wet sand to grind through granite and other hard stones. It's slow, patient, abrasive work rather than a clean slicing cut, and it leaves a very distinctive signature. Parallel striations, sometimes curved cores from tube drilling that have been documented on tools, too. L marks and unfinished pieces recovered from multiple sites, most famously by the pioneering engineer and Egyptologist Flinders Petrie in the late 19th century. Petrie recovered granite cores with spiral grooves cut by copper tube drills loaded with abrasive, and later researchers, including geologist Dennis Stocks, physically replicated the process, cutting granite with copper tubes and sand slurry and reproducing the same groove patterns seen on ancient artifacts. This is not speculation. It's a technique that has been tested, timed, and reproduced. But sand abrasion, sawing, and drilling explain fine work. Statues, sarcophagi, precision holes. They don't explain how you remove an entire trench of solid bedrock around a monument the size of the unfinished obelisk. For that, the primary tool was something much cruder and much more effective than it sounds, the dolerite pounder. Dolerite is a dense, fine-grained igneous rock. And critically, it is somewhat harder than the granite around Aswan, generally in the range of 6 to 7.5 on the Mohs scale, occasionally tougher, depending on the specific deposit. Egyptian quarry workers shaped dolerite into rounded, fist-sized to melon-sized balls, some weighing as little. A kilogram? Others reported in the range of 5 to 12 kilograms for two-handed use. They didn't slice with these. They pounded again and again in a controlled rhythm, crushing the granite's crystal structure into powder and small chips rather than cutting it. This isn't a fringe theory patched together to save an old textbook. It's directly supported. DC Today. Archaeologist Reginald Engelbach, who excavated and studied the unfinished obelisk in the 1920s, documented the pounding technique in detail. Zahi Hawass and subsequent survey teams have recovered more than 10,000 dolerite pounders scattered through the Aswan quarries, sitting exactly where they were abandoned, worn down from use. Some cracked from the very impacts that shaped the granite around them. You don't find 10,000 purpose-made percussion tools lying in a quarry by accident. You find them there because that's what was being used. The scoop marks themselves, the very feature at the center of the viral claim, are the direct physical signature of this pounding process, and their shape makes complete mechanical sense once you understand how repeated. Percussion actually behaves on crystalline rock. When you strike granite with a rounded stone tool at a controlled angle and force, the material doesn't shatter randomly in every direction. It tends to fail in a scallop, a shallow, concave scoop, because the impact concentrates stress in a roughly circular zone around the point of contact, and the crystal lattice fractures outward from there. Do this thousands of times in a row along a marked line, worker after worker, shift after shift, using pounders of broadly similar size because that's the size that fits comfortably in a human hand and delivers the right amount of force without shattering, and you get exactly what's carved into that trench. A field of overlapping scoops that looks rhythmic, almost woven, because the physics of the fracture and the ergonomics of the human body are themselves consistent. This is not evidence of a machine holding a fixed radius. It's evidence of what happens when hundreds of workers use the same category of tool on the same rock, following the same technique over and over for years. Consistency born from repetition is not the same thing as mechanical precision, but from a photograph, at a glance, they can look remarkably similar. That resemblance is the entire foundation of the viral claim, and it dissolves the moment you understand the material science underneath it. Researchers have actually gone out and tested this directly, rather than speculating about it from images. A 2022 photogrammetric study conducted at the unfinished obelisk site measured the rate at which modern volunteers, untrained in the technique, could remove granite using dolerite pounders on the same rock in the same trench conditions. The results showed that while the work is slow and physically demanding, it is entirely sufficient to explain the volume of material removed. Once you factor in organized teams working in shifts over the actual time frame the ancient Egyptians had available, which was not months but years, sometimes generations, for a single major monument, other experimental work has clocked roughly 15 to 20 cubic centimeters of granite, removed per worker per hour using this method. That number sounds tiny until you multiply it by dozens of workers pounding simultaneously along a trench for 8 or 10-hour days across weeks and months. The unfinished obelisk itself, notably, was never completed. It cracked during quarrying, likely due to a flaw in the granite that the ancient engineers discovered too late, and it was abandoned in place. That detail alone tells you something important. This was not an infallible super technology operating with mechanical certainty. It was a difficult, high-stakes human process, one where a hidden fracture in the stone could ruin years of labor. Machines don't get betrayed by a hairline crack they couldn't see. People, working by trial, judgment, and hard-won experience, do. None of this required the Egyptians to be primitive. Quite the opposite. What actually happened at Aswan is a masterclass in getting an extraordinarily difficult material to yield, using only stone, copper, sand, wood, water, and organized human lay. And it required real engineering intelligence to pull off. Before a single pounder struck the rock, surveyors marked the outline of the intended block using string lines coated in red ochre, snapped against the surface to leave a straight guide, essentially a chalk line 4,500 years before chalk lines were reinvented for the same purpose. Workers then see a trench along that outline, wide enough, roughly 75 centimeters in the case of the unfinished obelisk, for two people to stand and swing pounders in a controlled rhythm without hitting each other. As the trench deepened, the crew worked in relays, because pounding granite for hours on end is exhausting, and fatigue produces sloppy, inconsistent blows. Fresh workers rotating in kept the strike quality consistent, which is itself a very human, very practical way to solve the problem of maintaining uniform work over a long shift, no fixed machine radius required. Once the trench reached sufficient depth, separating the block from the bedrock underneath required a different technique entirely, because you cannot pound sideways underneath tons of stone. Here the evidence, along with reasonable engineering inference, points to a combination of fire and water, alongside continued percussion. There's long-standing debate over exactly how much fire setting was used in Egyptian granite quarrying specifically, since evidence is more securely documented for softer stones like limestone, but ash and charcoal deposits found near quarry trenches, including at Aswan, suggest it played some role, heating the rock's surface and then rapidly cooling it with water to induce thermal shock and encourage cracking along the desired plane, making the final separation from the bedrock more manageable. Wooden wedges were also used, particularly in softer or already fractured rock. Dry wedges driven into a crack, then soaked with water, so the wood expanded and forced the fracture wider. This is a genuinely elegant piece of low technology engineering, using a material property, the swelling force of wet wood, to do work no hand tool could do directly. Once free, blocks weighing many tons were moved using wooden sledges, levers, ramps, and D almost certainly wetted sand under the sledge runners to reduce friction, a technique confirmed by a well-known Middle Kingdom tomb painting at Deir el-Bersha, showing a worker pouring water directly in front of a sledge, hauling a colossal statue, a detail so precise that modern physics experiments have since demonstrated it actually reduces the required pulling force by roughly half. Now consider the scale this system had to operate at, because this is where the true achievement of Aswan lives, not in a hidden machine, but in the sheer organizational and logistical mastery required to move stone at this volume with only these methods. The Aswan quarries remained in continuous use for more than 3,000 years, from the Old Kingdom through the Roman period, an operational lifespan longer than the entire history of most modern nations. They were the only significant source of the hard red and pink granite prized for obelisks, sarcophagi, statues, and temple casing throughout. Pharaonic history, which meant every major obelisk raised at Karnak, every colossal royal statue, was born in this same trench and pounder process before ever leaving Aswan. And the logistics compound from there. After a block was freed, it still had to be dragged to the Nile, loaded onto a barge sturdy enough to carry hundreds of tons without capsizing, floated hundreds of kilometers downstream at the right season, when the Nile's flood level was high enough to get the barge close to the destination temple, then unloaded, dragged again, and finally raised into position, often to a precision of fractions of a degree in vertical alignment. Every one of those steps is a distinct engineering problem, solved without iron tools, without the wheel and any load-bearing capacity for stone this heavy, without draft animals capable of pulling tonnage like this, and solved well enough that some of these obelisks are still standing today in Rome, in Paris, and London, having outlasted the empires that later stole them. This is also where the honest, unresolved mysteries of Aswan actually live, and they're worth being straightforward about, because pretending archaeology has every answer is its own kind of dishonesty. The unfinished obelisk, had it been completed, would have stood around 42 meters tall and weighed in the region of 1,200 tons, making it by a wide margin the largest single piece of stone the Egyptians ever attempted to extract, and, if raised, the largest obelisk in history. We don't know precisely how they intended to lift a monolith of that mass to a vertical position, because no textual instruction manual survives, and the leading engineering models, involving massive earthen ramps, counterweighted sledges, and enormous teams of laborers, remain informed reconstructions rather than confirmed procedure. That is a genuine standing question in Egyptology, and it's a far more interesting one than a manufactured claim about machine tolerances, because it's a puzzle about human ingenuity operating at the absolute edge of what organized labor and simple machines can achieve, not a puzzle about a lost civilization's power tools. There's also the deep, narrow test pits scattered through parts of the Aswan bedrock, sometimes reaching considerable depth on a narrow footprint. Their exact purpose isn't settled with total certainty, but the leading, well-supported explanation is straightforward rather than exotic. They were exploratory borings, sunk to check the quality and continuity of the granite at depth, before committing enormous labor to extracting a full block above it, since a hidden crack or vein of weaker rock could ruin a monument years into the work, exactly as happened with the unfinished obelisk itself. Ancient quarrymen, working this stone for 3,000 years, would have developed a genuinely sophisticated practical understanding of how Aswan granite tends to fracture, where its natural planes of weakness run, and how to read the surface for warning signs, the same way a modern stonemason today can often predict how a block will split just by studying its grain and listening to the sound it makes when tapped. That is empirical, experience-based expertise, refined over dozens of human generations, not evidence of ground-penetrating radar. As for the idea that ancient rock art painted in red ochre sitting on top of certain marks proves a lost civilization predates dynastic Egypt by thousands of years, this claim mixes together two different things that were never demonstrated to be connected: the general presence of prehistoric rock art in the wider Nile region, which is real and well documented and can indeed predate the Pharaonic period by millennia, and the specific tool marks in the Aswan granite quarries. which are separately, securely dated by their direct association with inscribed, datable royal monuments like the unfinished obelisk itself, believed to have been commissioned during the reign of Hatshepsut in the 18th dynasty, roughly 3,500 years ago. No credible, peer-reviewed archaeological survey has documented ochre rock art layered directly over the obelisk quarry's precision. Scoop marks, in a way that establishes the tool marks predate the dynastic period. That specific claim appears to have originated in the same unverified online commentary as the AI analysis, not in any published excavation report. So where does that leave the actual answer to the question in the title? The method the ancient Egyptians used to cut granite was not a hidden machine and not a forgotten super technology. It was a layered system of low technology solutions, each one addressing a specific mechanical problem, stacked together with extraordinary organizational discipline. Dolerite percussion to remove bulk material through crystal fracture, copper tools charged with quartz sand to saw and drill with precision where fine detail mattered, fire and water to encourage controlled fracturing, along planes too deep to reach by hand, wet wood to widen cracks through hydraulic expansion, wetted sand to reduce sledge friction during transport, and a labor system sophisticated enough to coordinate all of it across a chain that ran from a quarry 600 miles up the Nile to temple courtyards where these stones were finally raised, sometimes with tolerances of a fraction of a degree. None of that required steel or wheels under heavy load or hidden electricity. It required time, an intimate, empirically earned knowledge of how granite actually behaves, and a level of coordinated human labor that modern audiences, accustomed to machines doing the heavy lifting, consistently underestimate. That, honestly, is the more shocking part of the story. Not that a machine did this in secret, but that people did it in the open, with tools you could hold in one hand, and left a record so precise and so well organized that scholars are still learning from it 4,500 years later. The scoop marks in that trench aren't evidence of a technology we lost. They're a fingerprint of a labor system we've barely begun to fully appreciate, a physical record of thousands of individual, deliberate human decisions, swing after swing, shift after shift, refined over centuries into something that still looks, at first glance, impossibly precise. It isn't a mystery that needs a machine to solve it. It's a monument to what disciplined, patient, coordinated human effort can actually do, and that deserves far more credit than the myth ever gave it. If this kind of deep dive into how ancient engineering actually worked is something you want more of, subscribe, because there's a lot more buried in these quarries worth digging into properly. And the next one is already in the works. Drop a comment with the ancient site you'd like examined next, with the same standard, real evidence over viral claims, and I'll read every one of them.